Hi, this is Mr. Manley. In this video, I'm going to be looking at linear functions, linear equations, and this should be pretty quick. This is review of algebra topics, algebra 2 topics for a pre-calculus class. Beginning with graphing a line. This is a line that is what we would call in standard position, and some students may like to convert this to the slope-intercept form. I like to do this because this is something that we're going to do for other functions as well. So I like to try to do this where I look at when x is 0, which is giving me the y-intercept. And like I said, that we're going to use this for future functions. So it may not be your favorite way to look at a linear function, but since we're going to be doing this for future functions, I'm going to start doing it now. And then I'm going to let y equal 0, and that's going to get me the x-intercept. So putting in a 0 for x, that's going to 0 this out and leave me with y equals -8. So that's the first point. And then letting y equal 0, it's going to 0 that out. And I've got negative 4x is equal to -8. So I would divide by -4, divide by -4. That's going to be -8 over -4, which is 2. So that'll be the x-intercept. We're going to graph those 2 points. 0, -8 is here, and 2, 0 there. And that's all we ever need for a line is 2 points. 2 points determine a line, and I've got the graph of the line. And remember that throughout. All I need is 2 points and I've got a line. Here's one that gives some students a little bit of trouble, is when we don't have an x and a y. So we have either just an x or just a y. So, I mean, I think it's pretty simple to think about that if you are looking at all points, all of the points where x is equal to 5, and you want to know what line is that? Well, think about that. Points, where does x equal 5? X equals 5 here. Equals 5 there. And then it equals 5 on all of these points here. Equals 5. And remember, I only need 2. But looking at a whole series of points where x is equal to 5. So x is equal to 5 is this vertical line at 5. And then the y one here is where I've got y is -8 down here, right? And then where else do I have y is -8? Right there. I just need one more. So I've got that. And draw a line through those points, and that's y equals -8. So you could get into this business of some sort of like memorizing x is vertical and y is horizontal, but just think about a couple of points. Just go, well, I've got a point here where x is 5 and another point where x is 5, and 2 points make a line. Okay? Okay, this is really going back. Slope of a line, just really breaking it down. Slope, m is the variable that we typically use for slope. The definition of slope is change in y over change in x. And so that's the Greek letter delta there. That's what that is, and delta means change. And change in y can be determined by y2 minus y1 over x2 minus x1. What are y1, x1, y2, x2? Well, those are up here. We call that x1, y1, x2, y2. And it's simply a case of plugging those values in. So I get 6 minus 2 over 9 minus negative 7, and that's 4 over 16, or 1/4. So that would be our slope over here, 1/4. Of course, that is a value or a calculation that is specific to lines. Lines have slopes. Here we're asked to find the slope and the y-intercept. Let's talk about the y-intercept first. Something that I want you to be locking into your head or into your brain is that the y-intercept is when x equals 0. When x equals 0, that's the y-intercept. So I would, for this equation, I would let x equal 0. So that's going to zero out. And then I have 2y equals 2. And we don't have to do the algebra here, but I'll just show divide by 2. So I got 2 over 2 is 1. And that's the y-intercept because I let x equal 0. So I've got the y-intercept at 1. And then I'm also asked for the slope here. So one way of doing the slope, and there are other ways, but one way of doing the slope is to solve for y. And we're going to put this in y equals mx plus b form. So in this case, I would isolate the y by subtracting 6x from both sides. So that's going to zero out here. And then I'm going to have 2y equal to, and just rearranging this so that it matches this form here with mx. So I'm going to rearrange it with negative 6x plus 2, divide by 2, and then I'm going to always just divide each term individually. I mean, I could divide the whole thing by 2, but I think it makes more sense as especially when we're looking for the slope, to divide this by 2 and to divide this by 2. And let's simplify each of those terms. So that's negative 3x plus 1. And there's our slope, right? Because the slope is mx. So there's the slope, negative 3. And those are the answers to those questions about slope and intercept. All right, here we're going to find the equation of a line that passes through the point 5,2 and has a slope of 3. Might be nice to conceptualize this, or do I mean contextualize it? Put it in context, what's actually happening. Just a really rough idea, right? I'm just going to do a really rough idea. So 5.52, let's say that's out here. Makes sense? 5 over and 2 up. So that's 0.52. And then I've got a slope of 3. Well, slope of 3, something that I didn't say about slope, I kind of jumped right in and said that slope is change in y over change in x. Another thing that we say about slope is that it is rise over run, right? So rise is the change in y, run is the change in x. So let's go here and say, yeah, I would have space over here. I would say I'm going to go up 3, 1, 2, 3. That's the rise, and a run of 1 over 1. So at that point there. So I got that point that I went up 1 over 3, and then I could have a line to that point, right? And that, again, that's 0.52. But what Yeah, what's the equation of the line? What is the equation of that line? We're going to lean on the y equals mx plus b. And we know the slope already. The slope here is a slope of 3. That goes in the equation right there for m. So I've got y equals 3x plus b. And then I need this b. I need the y-intercept. I can see it down here, some negative value. I could probably work my way to it. And if I'm lucky, I'd get to it exactly. So I could go down 3 over 1, down 3 over 1, down 3 over 1 until I cross the y-axis. But I might not cross it at an integer value anyway. I might cross it at an inconvenient fraction. So even if I have graph paper, I might not be able to get it exactly that way. But what am I going to do here? I'm going to take the other piece of information that I know, 5, 2. This 5, 2 is a value of, it's an x and y value that is on the line. I mean, we can see it right there. It's 5, 2 is on the line that we're talking about. And what does that mean? If it's on the line, it's also in the equation. 5, 2 is also in the equation. So that's where I'm going to put it. X is 5 and y is 2. And I've got the plus b, and that's what I want to know in order to finish the equation. I want to know what b is. That's easy enough to solve for, right? Subtract 15. 2 minus 15 is negative 13, which is equal to b. And I'm going to put this all together and say I've got y equals 3x minus 13. And when I did this here, I just put in one xy value that satisfies the equation. There are infinite xy values that satisfy the equation. And yeah, we're going back, I said we might not cross at an integer value. It turns out we would cross it at an integer value. So I could find that value by going down 3 over 1, down 3 over 1, down 3 over 1 until I get to the y-axis. Okay, and looks like that's it. So there is a review of some linear operations. Always the idea is that we are able to find the equation of the line, or we are able to graph the line.